Hey everybody, today I want to show you the just a fun graph that I put together. This idea came from the math art book. You may have seen me talk about this in the past or in other videos. I love this book for just trying to, like, when I don't have ideas, I love looking at it and seeing if I can recreate the stuff in there inside of Dynamo. I'm not a huge math guy, but I find this book really interesting for that reason. Just the different art pieces and trying to do it in Dynamo. One of the things he mentioned was the golden rectangle and the Fibonacci sequence. And what that looks like is like this. And I wanted to see if I could recreate that in Dynamo. Right off the bat, you can see there's an issue with the NURBS curve, but I didn't want to mess with it. But all the points that we need and all the lines are created, so that's all I cared about. So there's a few things that make up this graph. So we've got this over here, which creates the NURBS curve, and then also we create the rectangle over here. And then for the points and the lines that you see inside the rectangle, that's all created with these two graphs. This is also parametric, so if you flex this, it'll move it up and down. I capped it at 20 because the numbers get really big after a while. So this first Python script, all it does is it does the Fibonacci sequence. So this is the Fibonacci, whatever you call it, algorithm that takes in a number, and then down here just loops through the number that you input into it. And it just does that by creating a range. That part, you could Google that. You could find that. Just Google Fibonacci Python. That's all I did, and then I just copied it in here. This part was a bit of a headache. So I tried to do this last week in like a live video, or kind of live. It was just me recording me trying to do the graph, create the graph. But it was giving me a headache, and I came back to it this weekend to do it again. And this is the part that I mostly created. So between the two Python graphs, this I was getting a headache because I thought it was just easy to do, and then I realized that it was a bit more complex to get those points and those lines. The lines were easy because if you knew the points, you could easily figure out the lines, because the lines, the way that they're created, there's a logic to them. And so I was trying to think through it, and I find that helpful sometimes, is to step away and think through the problem. And so I was able to sit down and within an hour or so create this script. So not a ton of effort, but it was helpful, I think, to walk away and to come back to it. And the way that I've done it is I've created this while loop that loops through, and based off of the iteration that it's on, it will do a certain thing. It'll create it, all of these statements create a point and a line, but depending on where it's at in the iteration up here, it'll do something different, or it'll create the point differently, and then also the line. So you can see, like, the vectors. These are logic. There's a logic to how those lines are created. So in here, I just do -1, +1, and they switch, and you can see. And that's based off of the input here. This first if statement only runs once, and it only runs the first time you loop through the while loop. And then afterwards, these run depending on what's the iteration that you're on. And this is interesting, or this iterator, because I wasn't aware of this and just happened to learn about it. And I was like, hey, this could be a good time to use this. I do know, though, this graph could be improved, or this script could be improved. It's not, I think there's a better way, because there's a lot of redundancy in it. Is a lot of copy and paste for each of these elifs. So I know there's a better way to do this. And if you guys want to, all of this stuff's available. The description's below. If you guys want to tackle it, use it as an opportunity to learn, definitely go for it. But this iterator was kind of interesting, and I may not be using it the right way. I don't know what all the other methods that you can use with it are, but I thought this was a cool way to try to learn about it. And so we've got a list here. We've got 1, 2, 3, 4, just like you saw in there. There was 4 strings though. And so what we do is we take our list and we pass it into this iterator function. And then you can see now I is a list iterator. This next method, what it does is it takes in the iterator and then it moves to the next iteration every time you run through it. So now if we run it, this is the first time, you'll see that we get x1. And then if we go up here, x2, x3, 4, and then we get an error when it gets to 4. Here, there's an if statement that says that if x equals the last item in L, which is 4, then recreate the iterator. So now, run that. Now, if we come up here, click next, you'll see that it works, and now we're back at 1. So I've got that in here that'll tell us which parts of this we're at, and then if we get to this, it'll restart and it'll do this elif and move on until we don't have any numbers left in our end list. So that's how you do that, and I would recommend, if you want to learn more about this, just download it, play around with it, build upon it. That's a great way to learn just how this stuff works. And if it's just interesting, you want to play around with it, just feel free to use it however way you want. So that's how we get the lines, is with this Python graph, and that's how we get the points as well. And so here's these are our points, and then so there's our lines that we're getting. The outside rectangle is not a part of that. All I do for that one is I use a bounding box, and then with its mid and max points, I figure out the other 2 points, or actually just with the max point, I figure out the other 2 points, this one up here and that one, and then I plug it into this rectangle by corner points node, and then that creates our rectangles. And the purpose of that was just to recreate what you see here in this image. And then down here is your NURBS curve. So that's kind of it. I just wanted to show it. I thought it was kind of cool and kind of fun. I learn a lot when I develop these kinds of graphs. I learn a lot when I open up that book and just try to make cool stuff. A lot of times it's not the most practical things, but I think the knowledge gained from it is important, because when you get to a point where you have to loop through something or use some recursive function, or have a different approach to trying to solve a problem, I think these more abstract or more just unique issues, like this golden rectangle, open up or just change the way that you think about solving problems in Dynamo. That's what I'm trying to say, I guess, is that it just changes your thought process. And so when you try to approach an actual Revit project related Dynamo graph, having this stuff and knowing how to just work with geometry, abstract geometry types, just all the different things that Dynamo has, I think is really helpful in just your overall knowledge of using Dynamo and visual scripting tools. But each person's different. It helps me a lot, and that's all I'm trying to do, is just share this stuff with you guys, show you what my learning or how I learn Dynamo and how I do things, to just try to be helpful. So feel free to download this graph below and let me know if you have any questions. And yeah, and I will see you guys in the next video.